Hello guys, welcome to a new video. So in the last video we discussed about TCP and how the communication and everything takes place in TCP. But I also implied once that there is a limit to like even if it doesn't wait for the acknowledgement to come from the receiver side, like we discussed. Like after sending, let's say, one segment of data, it won't wait for device 2 to say that okay, I received that, then it will send data to it. That's not the case, like, because that's just wasted time and bandwidth. So basically, first of all, the device 2 has to send acknowledgement for every single data, and then also device 1 has to wait until it sends data to send the next data in the sequence, let's say data 2 or something. So that wasn't efficient. So what we discussed, that device 1 does is it will fire the data 1, 2, 3 and so on, and device 2 would send in sequences, of course, and device 2 would acknowledge them and tell device 1 the last data in the sequence that it received. Suppose it I was doing something else. Okay, let's say device 1 sends D1 and D2, data 1 and data 2 segments. Device 2 would acknowledge with D2, like these are in sequence, like assume 1 and 2 to be the serial numbers of it. So device 2 will send, okay, I received till data 2, like that's what it means. Like you can imply it in that sort of a manner. I received till data 2, you can send whatever is after data 2. And if any packet is lost in between, like let's say dev 1 also send D3, but device 1 send D3 as well, but device 2 send acknowledgement for D2. So what device 1 did was it sent till D3. Device 2 is like, no, I received till D2 only. So device 1 would just retransmit D3. So that was the case of retransmission that also we discussed in the last video. So now we come to the point that how much actually device 2 can handle, because let's assume let's take an example. Let's say let's take a classroom scenario where there is a student, there is a teacher. The teacher is dictating the student and the student is writing based on whatever the teacher is saying. If the teacher dictates very fast at a rate that the student cannot handle, like what would be the consequence of that? The consequence would be, like, it's obvious, of course, that student won't be able to keep up, and there will be missing words and stuff in the middle. So the whole writing, eventually, if you say like the student goes back and reads that at home, it won't make any sense, because many words or sentences the student missed in between because the teacher was sending the data very fast. Assume a similar kind of scenario here. Assume device 1 to be the teacher, device 2 to be the student. So device 1 would keep sending data without considering how much device 2 can handle. Then of course, like, the packets would be dropped, because device 2 will also need some time, because it has limited resources, limited amount of things that it can handle. So it will also need some time to handle the previous data, and that's how the whole thing takes place. And that's why the retransmission is also there. Like, let's say for some reason some packet is dropped while transmission, so device 2 can tell device 1 that okay, you sent till, like we discussed, if device 1 sends D1, D2, D3, and D3 gets lost somewhere, just assume like it gets lost somewhere in the between while transmission, device 2 would say that I received till D2, send everything after that. So device 1 would retransmit D3. It's a scenario like let's say the teacher says 4 words, student is like, okay, I heard till the 3rd word, I didn't get the 4th word, so the teacher would repeat that again for the student to keep up. So that can be a good example which you can correlate between both of the things. So that's basically flow control in a very simplified manner. But how is it handled in this case? Yeah, let's see. The first thing that we need to take care of is receiver window size. Receiver window size. So it's a very fancy term from at the first glance. Let me just draw this. Let's say this is the buffer. What is a buffer? A buffer is something like let's say whatever data comes for device 2, it would be stored here, which one by one device 2 will process, and as it processes, it will be cleared up. Basically, like, assume it is a storehouse sort of a thing where you store the data and you just When you are done with one, you move to the next one, and then you have empty space here to store more data. That's very like as simple as that. So yeah, let's say it has okay, I can make up for 5, I think. Okay, let's say it has a buffer of 5, like it's in bytes and stuff here, but for the sake of simplicity, let's say it can handle five segments at once. 5 segments as in these are segments. So let's say at times it can handle 5 segments like this, device 2. So whenever device 1 sends data, device 2 would initiate, device 2 would acknowledge, and it would tell it would tell that this is my window size, like this much is the data that I can handle, so take care of that. And that's how the whole transmission would take place throughout. So now let's say device 1 sends D1 and D2. How would it be processed? Okay, let me bring this to the middle. Okay, yeah. So let's say, okay, I'll just draw the arrow for easier understanding. This is on the receiver side, just remember that this is for device 2. This is for device 2. Okay, so when device 1 sends D1 and D2, it will be stored in the buffer first. Let's say device 2 is busy doing something else, so it will be stored in the buffer or memory or whatever you call it. Then after device 2 gets free, it will start processing these segments. Like it will process D1, it will process D2, and after both of them are processed, it would send an acknowledgement like okay, I am done till D2, you can send the rest. So this is the whole thing that's represented here itself. D1, D2, acknowledgement D2. Also there is the receiver window size, that okay, this much is the size that I can handle on my side, so just take care of that while sending the data, so that like no packets are dropped. Yeah, that's what. So basically then what they want to do is okay, so I should not send more than 5 at once, or like I shouldn't fire D2 with data so that it cannot handle it. So that will be taken care of on dev 1 side as well. We'll come to that. But basically after that, let's say it sends D3, D4. Okay, there is no space here, so what I do is, just remember these are different segments. I'm just putting it on the same line just for a sec, so that like I can cover it here itself. D5, D6, D7. Let's say this happens. Then what it would do is so basically D4, D5, D6. Acha, okay. D7, and we have D3 right here. Okay, that's what. So the buffer is full now, and any further data that dev1 sends without like waiting for acknowledgement, there's a high probability that that packet might be dropped. So let's say device 2 is done processing till D5. It's done. So now in the buffer we have D7 and D6. So let's say it sends D5, and then yeah, it says dev1 that okay, I'm done till D5. Then we have D7 and D6 here. So yeah, the basic thing that takes place initially that took place with the retransmission and transmission and everything. Basically the receiver window size is something that will tell device 1 that this much is the data that I can handle, and yeah, keep that in mind while sending any more data, like sending whatever data you send. Now there is something called sliding window on device 1 side as well. Let's say this one is 5, like we discussed. let's say it can handle 5 at once. Now we have till D1, D2, D3, D4, D5, D6, D7, D8, D9. Suppose you have 9 segments. Now what we would do? Okay, so let's say for first time we assume the selection to be the sliding window. Basically, it's sliding window. It's called because like it will start and it will keep moving towards the end. So let's say this is 5, right? So the size of it will be 5. Like there will be 5 elements or less than that inside it at a single time, and it would keep on moving towards the end. Suppose this can be the data for one sliding window. This can be the data for the next sliding window. After that, this can be the data for the next sliding window, and that's what. So that is the use case on how it operates. I'll just try to put it in a diagram for easier understanding. Okay, I think this should do it. Yeah, let's say data is D1 sends till D5. Okay, let's draw this down. So let's draw the whole sequence down. Device 1 sends till D5, as in till D5. So D1, D2, D3, D4, D5, everything. Then now what happens is, let's say device 2 acknowledges till D3. D3. So device 1 has sent till D5, device 2 will acknowledge till D3. So device 2 says, okay, I received data till D3, but D4 and D5 I'm not sure about. Like device 2 doesn't know that device 1 has sent them yet. So just for the case if it would need to retransmit in the future, it won't get rid of D4 and D5. Like for D1, D2, D3, it's sure that it's received by device 2, so there is no point keeping it on the sender side, because the sender knows that okay, device 2 received till D3, so I don't need to keep them on my end. But I sent till D5, right, from the sender side. D4 and D5 are still there somewhere in the internet, so let me keep track of those, just in case those packets are lost somewhere. I can just retransmit them. So what it would do is, just keep in mind the size of it. There are 5 elements in the window size at once, so it will drop till D2. Like till D2 I have no use, because I already know that device to receive till D2, I mean till second segment. So it would just slide it, it will just drop D1 and D2, and it will slide it till here. So that's the use case. That's the thing. Like it will keep on moving from start to end until the whole data transmission thing takes place. So on a very simple language, that's what it does. Basically, it keeps tracks of whatever data was sent, and it was confirmed that when the other device confirms that that I received it, it will just ignore or move on to the next part of it, from where the confirmation didn't come. So let's go through it once again. Device 1 send till D5, device 1 send till D5, device 2 said I received till D3. So device 1, now I have no use for D1 and D2 as in the first 2 segments, because it knows that D2 received it, so no point keeping them on the memory. So it will move the sliding window ahead, and it would include these 2 elements as well. So let's say after some time device 2 receives acknowledgement for D5 as well, let's say, because it's sent till 5 initially. Now the sliding window would move, it would drop data till D5, and it would retransmit this. So that's what the sliding window does. It keeps on moving until the transmission of the data is done, so that it can keep track of, basically it's like keeping track of whatever data whatever data was confirmed by D2 that I received it. So after receiving it, those are dropped. Like very simple. Assume this. Like D1 sends data. D1 will send like 2 to 3 segments of data. It will keep note of like, okay, these are the data that I have sent. I should receive the confirmation and then I can send the next one. It will receive confirmation for some data, and for whatever data I receive confirmation for, it would just drop them, and it would include like the next elements for those empty spaces, whatever comes in. So that's the concept behind sliding window. Nothing much complex. So yeah, that's the basics of flow control. That's how we control how much data one should send so that the other device can handle, so that data transfer can be very efficient in that way. Then we have the next thing, we have congestion control. We will discuss them in the next video. But yeah, that's different, like similar concept to flow control, but that's done on one level above it. So to summarize everything, basically what flow control is, like we in TCP, data is sent in together without waiting for device 2 to acknowledge. Reason being, if we were to wait for device 2 to acknowledge every single data every single time, that would result in wasted bandwidth and wasted time as well. So let's say there are 5 segments of data, 1, 2, 3, 4, 5. And let's say device 1 sends till segment 3, 1, 2, 3. Device 2 would send acknowledgement for the third data, like, okay, I received till data 3, you can send whatever is after that. Device 2 won't send acknowledgement for 1 and 2 because it would send since they are already in sequence. So if device 2 sends the last piece of data that it received that was in the sequence, that would make sense. So then device 1 will send from D4, D5, D6, D7, whatever, and the same thing will go on. And same is the logic for retransmission as well. Suppose device 1 send till D3, device 2 send acknowledgement for D2. Basically that means that device 1 send till D3, D1, D2, D3. Device 2 said, okay, I received till D2, as in just D1 and D2. So D3 will be retransmitted again. That's the concept of retransmission. And then the concept of flow control comes in. Like we cannot just keep bursting packets. Sorry, I keep saying packets. We cannot just keep bursting segments from device 1 and device 2. Because if we keep trying to push more data than device 2 can handle, it will just keep dropping the packets. That would lead in more and more retransmission, which would again lead in like wasted time and bandwidth. So we don't want to do that. So device 2 has something called receiver window size, which would signify how much it can handle at a time. So device 1 takes care of that by sending the data. Like this much is the maximum data that I can handle. So don't send me more data than this at once, otherwise the packets might be dropped. So device 1 takes care of that and waits and sends and waits and send, and whatever data it sends, it is kept track of using the sliding window like we discussed. Suppose this is the sliding window and it will be 5 here because D2 can handle 5 data at a time, so 5 segments of data at a time. So it sends till D5, it keeps track of it. Let's say it receives D3, so it knows that, okay, I sent till D5, but device 2 has received till D3, that's confirmed. So I don't need D1, D2 and D3 as of now, since that's already received. So it would move ahead. It would wait for acknowledgement for D4 and D5 maybe, or if it doesn't receive them, it would retransmit it. So that's it won't drop these two because it haven't received the acknowledgement for these two yet. It received till D3. Then if it received acknowledgement D5, so that means device 2 received the first 5 segments of data. So it would again move the sliding window ahead, and so on. Yeah, basically till data whole transmission of data takes place. After that, the connection is closed and everything. So yeah, that's the basic concept of flow control. Okay, yeah, so that should be it for this video, I guess. I hope it was helpful. If you have any doubts, you can always ask in the comments. And yeah, if you like the video, consider subscribing. Yeah, see you guys. Bye.